Okay, welcome Jack and Roxy and Marina and Vin and Nate and Luz and Maddie and Denise and Mary and Marquette and Jacqueline. Thanks for coming. And this is again our first class of week 2. And we're doing probability. And let me share my screen and let's go over the quiz that you just took. Hopefully it went well for all of you. Okay, so we have a few things you have to do. So write a paragraph that gives the pros and cons of using a histogram versus a box plot versus a stem and leaf for a presentation. Be sure to explain in what circumstances you would use each of the 3 charts and in what circumstances you would not use each of the 3 charts. Okay, so let's see, and let me put the chat box in. So maybe you can tell me what's good about a histogram. What does a histogram do that's especially good that maybe is not so good with the other 2?
It's really easy to look at and for pretty much anyone to interpret.
Yeah, so histograms. So because I'm going to be asking you to give me pieces, I'm not going to answer the question exactly because I'm not going to write a paragraph because I want to hear from you all. But histograms are user-friendly. Just about everyone understands them. Okay, any questions on a histogram so far? What else are histograms good for? That say box plots don't tell you.
A large amount of information.
Yeah, what information though? What information that does it give you that a box plot doesn't? Any thoughts? Okay, so if you don't know, histograms are great for showing the shape of the distribution. Yeah, shows the curve, and in statistics language, the shape of the distribution. Okay, we can also choose the width of the bars. Any questions about some good things that a histogram does? Okay, what about a box plot? What is a box plot really good? What is it like? What's its highlight?
It can like how do you say, handle a big group of numbers and then give
Okay.
you data. I don't know how to word that.
Okay, so it can be used. Used for large data sets. That's what you meant, right?
Yeah.
Yeah, 5 points of statistics. And what's the word box mean? What points of the box? So the left and right of the box are what? Do you remember?
Quarters?
Yeah, quartiles.
Quartiles.
So the box plot shows the quartiles and highlights the middle 50% of the data. Does that really well because that's a main thing for the box plot. Okay, what about the stem and leaf diagram? What does it tell you that the others don't? So what does the stem and leaf diagram tell you that the other two don't tell you?
Specific values?
Yeah. So stem and leaf diagrams don't lose the data value information. And I like the word specific. Okay, and in particular, you can find the exact mode. Okay, whereas a histogram bunches up data. So you actually can't find the exact mode. You can just find like what range has the most, but you can't find the exact value that has the most. And box plots are useless for modes. Okay. What are some of the issues or an issue about histograms?
They don't give exact numbers.
Yeah, histograms do not retain the exact data values. Information. What about box plots? What are the issues with box plots? What's the number one issue with box plot in giving a presentation?
Not many people are familiar with them.
Exactly, the general public is not familiar with box plots. So will not understand it if one is used in a general presentation. How about stem and leaf? What's the biggest issue with the stem and leaf?
The data points, while you do get all of them, are kind of hard to read.
Yeah, that could be an issue, but there's one big issue. And I mentioned it on Thursday. You remember? Stem and leaf diagrams cannot be used with large data sets. You just can't fit them on the paper. Does that make sense? Or the PowerPoint screen or whatever you're presenting. So you can't use a stem and leaf for large data sets. Also, they scare away number phobes.
I wouldn't say they scare away number phobes. They're just kind of hard to look at because it's like a lot to.
All right. Do you know the definition of a number phobe?
My
Me.
sister,
Someone who's afraid of numbers. What's a stem and leaf? It's a bunch of numbers. So by definition, they scare away number phobes. Does that make sense? Phobe means scared away from, by.
Oh, I'm aware of what phobe means.
Yeah. Yeah, so they scare away number phobes just by definition. Okay. Now, that doesn't mean if someone's little tiny bit number phobic, then they're like going to shut down. But if they're very number phobic, they will. Okay. But again, this is a paragraph. There are lots of things you can say. I'm not saying this, you all have to have word for word what I wrote, but I wanted to just kind of show you a bunch of the things, some of the pros and cons of a box plot, a stem and leaf, and a histogram. Okay. I'm not saying you had to have everything I wrote. And in fact, there's other things that I didn't write because I could write all day long. I just wrote some of the highlights to give you an idea of what a paragraph might look like. Does that make sense? Any questions on number one? Okay, number two is consider the data below that depicts the responses of a survey that asked cat owners how many times a day they pet their cat. And here we go, bunch of data values. Find the mean, median, interquartile range, standard deviation, Use z-scores to determine if there are any outliers. If there's outliers, list them. If not, explain why you know there are no outliers. So just to make life a lot easier, I'm just going to copy and paste this list. I highlighted, I hit Control C. If you're using a map, there's probably some copy. I don't know Max, but there's a way of doing it. And what number calculator do I need to use here?
The second one.
Yeah, number 2, one variable statistics calculator. So I click on that. And then the idea is I can just paste it in so I don't have to type them all again. It's a whole lot easier. Notice this is a sample, okay? Because there's a whole lot more cat owners than this list shows. So I'm going to click on sample standard deviation and hit calculate. Okay, did that look hard?
No.
Okay, but of course I did it. It's always easier to watch me do it, right? Okay, but I do want to give you a note. One is that this is what's called a formative assessment. That means that your grade hardly depends on it at all in terms of the points you get. On the other hand, if you didn't do well on it, what you really need to do is practice these kind of problems a lot before the exam. And the exam is the summative assessment. That's where the big points are. So again, if you did well on this, great, you're in great shape, you're on the right track, you've got it. If you didn't do well, that means you need to practice more. Doesn't mean your grade is dying because you didn't get a good score, but it means that you need to practice more, because if you get the same score on the exam that you got on this, then your grade will die. So it's just a note for suggestion on doing well. And again, if you're confused about this, then I'm here to help. Braulio is also here to help. Get some help. That's important. I have office hours. Braulio has lots of hours, and we can help you out. So just a note that if you had any issues, that those are things you can do. And was my promise right that the calculator is embedded right in the question? Do you understand now what I was talking about? Hopefully it was easy for you too. All right, so now we just answer the question. We want to find the mean, median, IQR, standard deviation. So the mean is 18.92. So let's write this out. And in fact, I think I'm going to write down equals X bar. There is a way of getting it in Canvas with the bar on top, but I don't want to spend the effort showing you how. It's a lot of work. So I'm just going to call it X bar, and that's fine.
I have a question.
Mhm.
If we didn't type it out like you did just now, is it still correct? Like if you get 18.92, but you didn't put mean equals X bar?
Somewhere you have to tell me that you're talking about the mean.
Oh no, I put mean, but I didn't put X bar.
That's fine. That's fine. The reason I put X bar is that sometimes on exams, for example, you'll see the symbol X bar, but I'll have it with the bar on top. So I want you to be familiar with it.
Okay.
That's the main thing. In your project, I don't want you to write X BAR. I want you to write X with the bar on top of it. And if you don't know how to do that, those are the kind of things that I can help you with. Does that make sense? Because projects, you have like, I wouldn't say unlimited amount of time, but you have weeks to do the project. Quiz is different. That's what I'm saying. I put it here to remind you that it's called X bar, not to say you have to do this. Okay, but you should label that it's a mean. Okay, and just go through. Then we're also supposed to get the median is 18. And then we're supposed to get the interquartile range. How do we get the interquartile range? Yeah, Q3 minus Q1. Again, that's the kind of thing where you don't need a fancy calculator to do that. Once it gives you Q3 and Q1, it's just 18.5 minus 17. I'm going to write IQR, so I don't have to write down that whole big long word, is equal to 18.5 minus 17. And that is 1.5. Okay. And hopefully you can actually do this in your head, but if you can't, you can always go to the bottom and hit scientific calculator. And then you can type it in and then it'll work. So you just type in right there, 18.5 minus 17. And then, did it give you there? Let's see. Oh, there it is, 1.5. Just had to scroll to the right. Okay. And then we were also asked the standard deviation. Standard deviation is 6.5569. SD, let me write equals S for standard deviation equals, once again, 16 point, let's copy and paste so I don't have to memorize the whole thing, 6.5569.
Is it okay if we rounded it to like?
Absolutely. The reason I'm not rounding is it's a lot easier to copy and paste it. But if you want to round, if you want to round, that's fine. If you wrote, 6.6, that's fine. But copy and pasting is easier, don't you think? Then you don't have to type anything. But again, you're welcome to round it. That's the kind of, now just a note on the assignments, the chapter assignments, it's pickier about number decimal places. So it'll usually give instructions on how many and follow the instructions. Does that make sense? Quizzes, I'm not picky about, as long as, it's clear that you know what you're doing. Okay, then I'm supposed to use z-scores to determine if there are any outliers. Okay, so let's go. So to find outliers, let's first find the minimum. The minimum is 5. So we can take, I'm just going to call it Z5 equals, now we just take 5 minus the mean, 18.92, and then divided by the standard deviation, which is 6.5569. Any questions so far? I can pop that in the calculator. I think it allows it, we'll see. And I get negative 2.1. This one I'll round because it's way too many decimals. Is it an outlier? What do you think?
Yes.
Yeah, and how do we know? Remember how we define outliers? Don't see y'all jumping in. It's less than negative 2. So if it's less than negative 2 or greater than 2, it's an outlier. So 5 is an outlier. We should probably do the same thing for the next number. Okay, and the next smallest number looks like 16. Let's double check, but I'm pretty sure.
Did we have to do that for all the data points?
No, see, once you find the next number and it's not an outlier, then you don't have to go any more except the highest and do the same thing on the side. So 16. And I'm going to do a big fat copy and paste because it's basically everything the same. 16, and I get 16 minus 18.92 over 6.55. That's clearly greater than negative 2. Okay, because we're looking at, this is actually greater than 3 divided by 7, which is not even negative 1. or greater than negative 3 divided by 7. So we can say 16 is not an outlier. Okay, next, let's check out the maximum. So the maximum is 41. So I do 41 minus 18.92 divided by 6.5569. I'm going to copy that, paste it into the calculator. And I didn't put in, just a minute. It was, I forgot to change that to 41. There we go. And let's make that a 41 now. And that's 3.4. What's the important thing about 3.4?
It's greater than negative 2.
Greater than 2. So you have to be outside of the negative 2 to 2 range. Does that make sense? And in fact, yeah, I like what you said, Jack. It's an extreme outlier. So 41 is an extreme outlier. Okay, now let's do the same thing with the next highest number. And the next highest number along these lines, I see 36. So do the same thing with 36. Make that 41 a 36. And it's 2.6. That's still greater than 2. So 36 is an outlier. It's not extreme, though. And now, finally, let's go to the next one. Maybe finally, but we'll find out in a minute. So the next highest is 21, I believe. So if we plug in 21 instead, and 21 minus 18.92 over 6.5 is clearly less than 2. So 21 is not an outlier. So the outliers are, I forgot to write 21. So the outliers are 5, 36, and did I lose my 41? I think I lost my 41. Yep. Let me write down 41. And that was greater than 3, actually. So 41 is an extreme outlier. I did it, but I think I changed it when I got to 36. So the outliers are 5, 36, and 41. Any questions at all? Any questions at all on this quiz? Any questions? Okay. So if there's no questions, let's get back to new material now. Or actually before that, any questions about anything else? This is a good time to ask if you have any questions about maybe a assignment problem you're working on or something about the class. Any thoughts, any questions? If I make the quizzes too long, then we don't. Then I'll have to rush through the whole class. I try not to make the quizzes that long. It takes a long time for me to explain them. A few minutes more than the 20 minutes, but yeah, I'm going to try and keep it at 20 minutes. Maybe I'll try and make them a little shorter, but make sure that you focus on trying to do your best on them. Because again, if I make them longer, then we have less time for class. So they're little quick quizzes. They do a couple things. One, they get you to zoom in, and the other one is they give you a heads up. That's all it's really about. It's not worth many points. That's a big thing to note. So don't stress about the quizzes, but do your best on them. Okay, so I'll try to make the quizzes a little shorter. Okay, whereas I don't want to change the time, but that's what I can do. Usually they're not going to write a full paragraph, by the way. There aren't too many of those.
Okay, that's probably why I took so long. I wrote I wrote a whole paragraph.
Yeah, so this was a paragraph, and that might have taken that. People write in different speeds. It's hard for me to know. There's gonna be a lot of writing, but it's more going to be a sentence than a paragraph in this class, but not for the next few weeks. So in about 3 weeks, then the writing starts again. But there's very little writing in this chapter. Chapter 3, pretty much nothing in chapter 4, nothing in chapter 5, almost nothing. Chapter 6 has pretty much nothing. Chapter 7 has very little. And then chapter 8 has a lot. Just to let you know how the class goes. So if that makes you happy, then at least you'll be a little comfortable for a while. Okay, any other questions? Okay, if there's not any more questions, what I'm going to do is I'm going to see how much you know, because you might not. You might know some, maybe not. Let me ask you something. Are you familiar with cards? Is anyone not familiar with just cards? Things like how many cards there are, what it means to be a king of clubs. Because I know that in the new generation, fewer people are playing, but did anyone need a refresher on what a card deck looks like? Speak now, forever hold your peace. Okay, so if you don't need a refresher, then yeah, 52 in a deck. 52 in a deck, 4 suits, 13 values, and 4 times 13 is 52. So that's why it's 52. So here's the next question I have. I have these cards. And the question is, if I pick one, so I'm going to mix them up. And I pick a card. What is the probability that this card is an ace? See, if some of you might be able to come up with it, and if you can't, that's okay.
Uh, 7.6%.
Fractions are better in this case. And my guess is you didn't do it in your head, but you might have. Fractions are better because they tell a story a little better. And I like what some of you said. And the answer was 4 over 52. Okay, and the interesting thing, this is the one time in math where I actually discourage you from reducing the fraction. Right? You're probably like used to always having to reduce the fraction, whether you like that or not, you kind of had to. But it's actually better not to reduce it because I think the story is told better with it not reduced. So P of ace is equal to 4 over 52. So the symbol I use for probability is P. Mathematicians are pretty boring. So we just use whatever the first letter is. Okay. Sometimes you write ace, you could write A too, that's fine too. And it's 4 out of 52. Okay, that's the probability that this card is an ace. Any questions on that? How do we get the 4 and how do we get the 52? So how did the 4 happen?
There are 4 aces in a deck of cards and 52 cards total. So
Right.
I realized I just wrote that in the chat. Sorry.
Yep. No, that's perfect. So there's 4 aces. So if you look at this event called ace, and we say how many of them are there, there's 4 of them. And if you look at all the different things that can happen, there's 52 of them. Any questions on that idea? So the good news is I'm ready to state the definition of probability. And let's put this in red because it's a really important one. So the definition of probability is the probability of an event, let's call it A, occurring, is the number of ways A can occur divided by the total number of ways of things that can occur. Okay, or in symbols. So now I'm going to write a insert equation. So in symbols, the probability of any event A is equal to the fraction. It's always going to be a fraction. And that is going to be the number in A. And I know small, I'll make it bigger in a moment, divided by the total number pop in the entire set. And that's the probability. Looks easy, doesn't it? Right? I gave you an example. Most of you got it. No problem, right? Okay. Do you think this is going to get harder?
Yeah.
Oh yeah. Yeah, it's going to get a lot harder. Okay. I like doing cards. One thing is that I had a background with cards. Also, it works really well with probabilities, but I'll do other examples too besides cards. And I wouldn't ask you a card question on an exam because I can't assume you know what cards are. Just let you know that. But I can do them in lecture at least. So that wasn't too hard, but it gets a lot harder. So for example, and we're not going to do this one, but just let you know how hard something could be. What if you picked 5 cards and you wanted to find out what's the probability that you got a straight, which means 5 cards all in a row. Okay, if you can come up with that, I'll be
5 cards of the same suit, or
no. So like 6, 7, 8, 9, 10 is a straight, or 2, 3, 4, 5, 6, or 9, 10, Jack, Queen, King. Those are all straights. Suit is irrelevant. And the answer is it's very hard. Okay, and the reason is the number in A is very hard. And the number in the entire set is actually very hard also. But the number in A is really brutal. Okay, harder than we're going to do in this class. but I want to let you know that these probabilities get really tough. Any questions so far? Okay, so far so good. Any questions? Okay, let's do some more of these. Let's instead, now I'm going to pick 2 cards. All right, here's 2 cards. What's the probability that these 2 cards that I picked are both kings? So we say it a pair of kings. That's harder. Do you agree? Not impossible. We can do that in this class. So what's the probability that they're both kings? Any questions on the question? All right, so the way to do that is first I'm going to find the probability that the first card is a king. That's easy. What's the probability that the first card is a king? Yeah, it's not 1 over 52. Remember, the probability the first was an ace was 4 out of 52. That's a hint. Big, fat, easy hint. So what is it? What's the probability the first card is a king?
Four and 52.
Yeah, 4 out of 52. Right? It's no different than an ace. It's not like kings are different than aces. I mean, they look different, but the probabilities are the same because there's 4 kings and there are 52 cards in the deck. Any questions on that? Okay, so now what I'm going to do is I'm going to say, well, if we didn't get a king, we give up. Do you agree? If the first card wasn't a king, you didn't get both kings. Are you all good with that? But if the first card was a king, so here's a king. What's the probability the second card's a king? By the way, these are cat cards because I love cats. So what's the probability that the second one is a king?
3 and 51.
Yeah, so let's talk about that because I also see some other guesses. Okay, so the idea here is we want to say we already know that it's not the king of diamonds because we see the king of diamonds and the second card can't be the king of diamonds. So instead, there aren't 4 kings left. There's only 3 kings left. Any questions on that? So there are 3 kings left that could be chosen from. Okay, we also know that out of all the possible cards the second card could be, it's not the king of diamonds. But there's 51 other cards the second card could be. So that's why the denominator is 51. Any questions on that? Okay. And at this point, you can stick it in a calculator, probably best at this point. Again, I'm not going to make you do, heavy fraction use. You have to be able to write fractions, but, I'm not going to have you reduce fractions in, kind of brutal. I could do this, but you're not responsible for that. So what is that? 17 times 13. Yeah, it's a mess. Okay, but instead you can go 12 over 52 times 51. Let's just do that. 12 over 52 times 51. And you get 0.0045 about. Any questions on that? Any questions at all? Okay, now comes a harder question. So suppose you pick 5 cards for a poker hand. What is the probability of getting a royal flush? Now, I don't expect you to know what one is, but my guess is someone in the class does. Can you tell everyone what a royal flush means? What does it mean to get a royal flush? It's got to be someone who knows poker, even the basics.
Royal flush. Ace high, straight flush, a hand consisting of cards ace, king, queen, jack, and 10 of the same suit.
Exactly. That's a royal flush. Ace, king, queen.
I Googled it.
Yeah. Oh, Google's good. Google knows everything. Ace, king, queen, jack, 10 of the same suit. So let's find out. So the probability of a, let's call it RF for royal flush, is equal to, well, it's going to be a fraction. How many ways are there of getting a royal flush? How many different royal flushes are there?
4?
Yeah, there's 4. You can get ace, king, queen, jack, 10 of spades, ace, king, queen, jack, 10 of diamonds, ace, king, queen, jack, 10 of hearts, and ace, king, queen, jack, 10 of clubs. There's 4 of them. Easy enough? Now comes the hard part. How many different ways are there of picking 5 cards out of a deck of 52? And I don't expect anybody to know that one offhand. But here's what we can do. We can use the calculator. So this is called combinations. And number 5 is combinations and permutations. And what combinations do is they say, how many ways are there of picking a certain amount from a larger collection? So in this case, the larger collection is 52 cards. And how many cards are we picking?
5.
5. And just a note, when you play poker, order doesn't matter. So if your cards are king, ace, jack, queen, 10 of clubs, that's still a royal flush. So no one cares about the order at which you have your cards. All that matters is your 5 cards. So if you don't know poker, just trust me on that. So if the order does matter, then it's this PNR. But if the order doesn't matter, it's CNR. So I click CNR, and it's big, 2.5 million. So 2598960. Okay. So by the way, if you got a royal flush, if you picked 5 cards and you got a royal flush, would you be surprised? What do you think? Or you'd be like, yeah, that happens. That's normal. What do you think?
No, you'd be surprised.
You'd be incredibly surprised. Okay. We're talking about like less than 1.5 million probability. Any questions on that? Okay. So this is all fun and good. One time in the 6th grade, you guessed on all questions right on a 20-question 4-answer multiple choice quiz. Okay. And that is hard, by the way. Okay. Let me do that since you brought it up. Suppose. See what happens? You bring it up and now we're going to do it. suppose you guess randomly on a 20 question, 4 answer, multiple choice quiz. Find the probability of getting them all right. Okay. So I'm glad you brought this up. So thanks a lot for bringing this one up, because it brings up something that's very important. And if you guessed A for the first question, are you allowed to guess A for the second question?
Yes.
Yes. So when you're allowed to repeat what you just did, that's called with replacement. So let me write this down. Yeah, I wouldn't recommend guessing, and we'll see what happens. We'll see the probability. We haven't gotten to the probability, but we'll find it. This is called with replacement. Whereas the poker example is without replacement, right? Once you've picked the ace of hearts, or sorry, the ace of clubs, the next card is not going to be the ace of clubs. It's not possible. But on a multiple choice quiz, if you picked A on the first question, you could pick A in the second. So this is with replacement. And when it's with replacement, it's actually much easier. Because what we can do is, let's do this. We want the probability of all correct. Finish 30 seconds, all it takes. But I wouldn't count on it for my exam, by the way, because we'll see what the probability is. Okay, so the probability of all correct. Well, let's just see the first one. What's the probability that the first is correct? What's the probability of the first answer? Your first answer is correct.
1 in 4.
1 in 4. Times. What's the probability the second is correct? Hint is it's really easy. Also 1 in 4. What's the probability the third is correct?
1 in 4.
1 in 4. I'm not going to write them all out because it's boring. I'm going to go dot, dot, dot times 1 in 4. And there's 20 of those. Mathematically, how do you rewrite that? When you multiply the same number over and over and over again, what is that? Because we don't want to have to put this in the calculator like it is. Yeah, it's 1 in 4 to the 20th power. Any questions on that? Any questions? And that is a, let's see, kilo. That is a giga probability. You've heard of like megabyte and gigabyte. That's what a giga is. Just let you know that. And we could do 1 in 4 to the 20th. Let's make this bigger because it's hard to read. So let's calculate that out. I'm going to go 0.25. 1 in 4 is a quarter, 0.25 to the 20th power. Okay, if you see this e negative 3, what does that mean?
It means
that,
it keeps going.
What does it mean? Very small, but no, but what exactly does it mean?
It means it keeps going for what, like 13 more decimal places or something?
It's a good idea, but that's not true. Okay. Where you put the chat is not quite right because the decimal place is in the wrong spot. It means move the decimal place to the left 13 places. So the first place moves it just next to the 9, and then each of the others, you have to insert a new 0. So you can have a decimal point, 12 zeros, and a 9. That's what the E-13 means. So equals 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a 9. All right. So you should be shocked if you get this. Most of you probably don't even know how to read this number, right? Because what? That's 1,000, a million, a billion, a trillion. Okay, so that is 9 in 10 trillion chances. That's how you read that. Any questions on that? So if that really happened, that's pretty amazing. All right, now comes the next question. Is also going to be difficult, but if it occurs, it's going to be a whole lot, and I promise you, better for me if it happens than getting the 20 right on the test. And it's this. Can you see what this is? Can you all see that? Okay, what am I looking at?
Lottery ticket.
A lottery ticket. Okay, and this is Mega Millions, by the way. There's lots of choices for lottery tickets.
This for tomorrow's draw.
No, actually, I'm gonna be a 200 millionaire tonight. Okay, should I start like getting some bank loans and stuff because I'm gonna win? What do you think?
No.
So what is the probability of me winning the Mega Millions?
It depends on how many people bought lottery tickets for this specific.
Actually, it doesn't. Everyone says that. That's funny. It doesn't depend on how many people bought lottery tickets. If a lot of people bought more than one wins, I still won. I just win less money, but I still win the Mega Millions. Does that make sense? We just share. So it actually makes no difference on how many people bought it. So it's nothing to do with the total number of tickets.
So it has to do with like how many number combinations you could pick.
Exactly. So what we need to do, because my guess is none of you know exactly how it works. So that's what the internet is for. Okay. And by the way, do you see why I decided to buy a Mega Millions ticket instead of a Powerball or a Super Lotto Plus?
Yeah.
Yeah, I'm greedy. I always go for the biggie. So Mega Millions. Okay. And by the way, do you know how many times I've won? I buy it every time I'm about to teach this class for this lecture. And I've been teaching a lot of years. How many times do you think I've won?
Not a lot because you're still a professor.
Yeah, or never. Actually, I should tell you, if I win, I'm not going to quit my job. I still like teaching.
I'd
So
quit.
that won't change.
That's awesome.
What's that?
I'd quit.
Yeah. Well, you don't want me to quit. If I quit, this class gets canceled.
Oh, then in that case, yeah, don't.
Yeah, don't.
Yeah, no,
but
I
I'm not,
need this
I
to
probably won't.
transfer, otherwise I lose the spot.
Right, but I wouldn't quit. But I would donate a lot of my money to charity. That I would do for sure. Maybe even get you guys some dorms when we can get back and actually, be to normal again. So let's take a look at Mega Millions and let's see how to play. And if you hit how to play, there's 5 steps, but really the first step is all we need. And that is using the lottery play slips. You can find at any lottery retailer, okay? I bought it at the gas station nearby. Pick 5 numbers between 1 and 70 and 1 mega number between 1 and 25. Okay? So that's what we need to know. So 5 numbers. In fact, let's just copy and paste this into Google. So that's the rules. And we want the probability of winning. Okay. Any questions on our goal? Okay, the first thing, and you probably didn't notice, but let me show you again. Can you see how many sets of numbers did I buy? Can you see it?
Three, 6.
Yeah, so I bought 3 sets of numbers. It cost me $6, by the way. Okay. So there needs to be a numerator, there needs to be a denominator. What's the numerator? Hint is it's really easy. So what's the numerator? It's easy, I promise. How many ways are there that I could win?
3.
3, because I bought 3 tickets. There's 3 collections of numbers that make me win because I got 3 sets of numbers. Any questions on that? So hopefully you agree that was easy because there's 3 ways to make me win. Now we need to figure out how many different ways are there of picking lottery numbers. How many different tickets could be bought? Okay, distinct tickets. So how do I find how many ways are there to picking numbers between 1 and 70? And by the way, its order doesn't matter, and it is without replacement. So how do I find that out? Do you remember? Here's a hint. Remember how I did that? It's very similar to the royal flush one. Pick 5 numbers from 1 to 70. I go to my combinations and permutations calculator and want to see how many ways are picking 5 numbers from 1 to 70. So now n is 70. And we're picking 5 numbers, so that's still 5. Any questions on that? And then I calculate. Okay, and I probably should fix this. That's in my to-do list. Is it should round to the nearest whole number. So this is 1, 2, 1, 0, 3, 0, 1, 3, but it's really 0, 1, 4. So I'm going to do this to remind myself. I'm going to take that 0.9 and make it a 4. Is that the answer? Or am I missing something? What do you think? Here's a hint. Read the instructions.
You also have to pick a number between 1 and 25.
Exactly. I got to pick a number between 1 and 25. And by the way, those are independent of each other. You can actually have one of the mega numbers, your mega number be one of your 5 numbers. Okay. And because of that, I'm allowed to multiply. If not, you can't multiply. So I'm going to multiply. How many ways are there of picking a number between 1 and 25?
25.
Yeah, it's 25. Okay, very easy question, right? You don't need a calculator for that one. So there's our answer. Let's get it as a decimal. So we're gonna have 3 over this mess. So I can go into the other calculator. So I have 3 divided by, I think it's still in there, good. And let's make that a 4 times 25. And there's my probability of winning. Notice the E-9, that means I need to move the decimal 9 places. So you can have 8 zeros before the 9. So it's 8 zeros and then a 9, 9. Okay, this guy. So that's going to be 0.12345678999, or about, I think it's one of these. There it is. 0.1234567 and a 1. Kind of rounded a little bit better. So what do you think? Do you think I'm going to win?
Probably not, but
Probably not.
I can say
Okay.
anyway.
Could it happen? Yeah, but this is 1 in 100 million, by the way. So the probability that this is a winning ticket is 1 in 100 million chances. So here's my suggestion for you. I don't recommend coming to my house with a gun to steal my ticket so that you can get the $200 million, given that there's only 1 in 100 million chance of it winning. It's probably not a very good thing to rob and steal. Do you agree? Any questions about this example? Okay, who knows? I'll be checking tonight. Maybe I'll win, but I won't tell you until after I've, turned it in. So I think we should take a break because we're supposed to take a break. It's 4:57. So I'm going to stop my share. And I'm going to pause the recording.